So in today's lesson, we're looking at factorising quadratics. This is the first of the next few lessons where we're going to be focusing on this. You already looked at factorising linear expressions, and we're going to start by just reminding ourselves of some key vocabulary. So when we factorise, we're looking to simplify an expression by finding a common factor that divides all the terms in the expression and taking that outside of the brackets. We write an answer to a question that says factorize with a value outside a set of brackets. And remember, when you're doing that factor, it's got to be a number or a term that divides another without leaving any remainder. And that could be just a number, it could be a constant, or it could be a letter, so a variable, or it could be a combination of the both, the two of them. We've then got some key terms to help us with referencing and talking about quadratics. So the word coefficient, that's the number in front of a letter. It tells you how many lots of the variable that you have. So in something like 3a, the coefficient of a would be 3. In the expression 7b squared, the coefficient of b squared would be 7. We're going to have constants. They're numbers that never change, so they are just numbers by themselves. So 3 would be a constant, 8 would be a constant, -2, 7.5, -0.5. They're all constants. And then the partner to that is variable. And a variable is a term that can have different values. And in maths, we use letters to represent variables. So a is a variable, or b squared is a variable. A quadratic expression is an expression that contains a squared term, but no higher powers. So something like x squared plus 3x minus 2 would be quadratic, but x cubed minus 2x squared plus 7 wouldn't be, because there's an x cubed term in there. We then have monic quadratic expressions, and that's a quadratic expression where the coefficient of the squared term is 1. So something like x squared plus 3x plus 2, there's no coefficient other than 1 in front of x squared. Something like 3x squared plus 7x wouldn't be a monic quadratic expression. And then we have linear expressions, which are ones which have no powers at all. So something like 3x plus 2. So from here, we're going to look and we're going to find linear expressions, quadratic expressions, linear expressions with the next coefficient of 3, and a quadratic expression with a constant of 5. I'll give you a moment to do that. You can pause the video if you want. And here are the answers. So the linear expressions are 3x minus 8, 4x plus 9, and 12 minus 4x. They're the ones which don't have a squared term in. The quadratic expressions, x squared plus 3x plus 5, x squared minus 2x minus 7, and 3x squared minus 4x plus 7. And of those, the monic quadratic expressions are x squared plus 3x plus 5 and x squared minus 2x minus 7. 3x squared minus 4x plus 7 isn't a monic quadratic expression because the coefficient of x squared is 3. We then have the linear expression with an x coefficient of 3 is 3x minus 8. It's the linear one, it doesn't have an x squared in it, and the number in front of the x is 3. And the quadratic expression with a constant of 5 is x squared plus 3x plus 5. 5 is always going to be 5 no matter what the value of x is. Now, we've so far looked at factorising linear expressions, but when we factorise quadratics, we are doing the opposite of expanding brackets, much like when we factorise linear expressions. Linear expressions, when you expand the brackets, you're taking the brackets out and multiplying. With quadratic expressions, we're putting brackets back in. So the expression x plus 3x plus 5 becomes x squared plus 3x plus 5x plus 15, which simplifies to x squared plus 8x plus 15. Now, reversing that is a bit more of a problem. So we need to reverse this. Now, there isn't a common factor of x squared plus 8x plus 15. That's a constant. Nothing goes into 8, 15, and 1. And there isn't a common factor that's a variable. X goes into x squared and 8x, but it doesn't go into 15. So we need to reverse this, and unsurprisingly, given that we start with 2 sets of brackets, we have to end with 2 sets of brackets if we were going backwards. Now, the key thing to notice is that the constant in the expression, 15, is the product of the 2 numbers in the brackets, the 3 and the 5. And this will be the case for every quadratic expression, that the constant, will always be the product of the 2 constants in the brackets. If we look at our grid, the only thing that affects the constant is just that bottom right square there, which comes from the 3 and the 5. So that gives us one hint. We need to look for a pair of numbers that would multiply to make 15. Now, the second thing is that the coefficient of x, the 8 here, is the sum of the 2 numbers, 3 and 5. So we're looking for 2 numbers then that add together to make 8. So to find our numbers in our brackets here, we're looking for 2 numbers that multiply to make 15, that add together to make 8. Now, obviously, with this one, we can easily see that's 3 and 5 because that's where we got the question from. But generally, spotting that makes factorising much easier to do. So we can see it again here, x plus 7, x plus 6. 6 times 7 gives us 42. 6 add 7 gives us our coefficient of x, which is 13. So if we were working backwards, we'd have to think what 2 numbers multiply to give 42 and add to make 13. Now, that's a really key point. And that's what we're going to be going into in our next lesson. But our first thing is just practicing finding those pairs of numbers. So if you give them a question, what 2 numbers have a product of 12 and a sum of 8? And sometimes you can just see what the numbers will be. You'll just look at it and you'll go, oh, it's this and this. But if you can't, you should always start by looking for the product. What numbers multiply together. Now, the reason we look for the product is because there are infinite pairs of integers that sum to 8. Just thinking of whole numbers, 0 and 8, 1 and 7, 2 and 6, 3 and 5, 4 and 4. But when you then include negatives, negative 1 and 9, negative 2 and 10, negative 3 and 11, that list is endless, literally infinite. However, the list of integers, remember we only talk about integers because we're just talking about factors, that have a product of 12 are much smaller. So the integers that have a product of 12, 1 and 12, 2 and 6, 3 and 4, negative 1 and negative 12, negative 2 and negative 6, negative 3 and negative 4. There's only 6 such pairs here. And that's when we include the negatives as well. So we can then add each of those pairs. 1 plus 12 is 13, 2 plus 6 is 8. I mean, we've already got our answer with that second one. We'll just put the rest here for completeness. And the pair that we're then looking for are the pair 2 and 6. When we do that, if we write all those products out first, it can then help us to find the answer. And like I say, sometimes you'll do it just by looking at it. You'll just see what it should be. The 2 numbers that have a product of 12 and a sum of 8, you might be able to look at that and go, oh, it's 2 and 6. And sometimes you'll be able to do that. But sometimes you might need to go through this process of writing out all the factor pairs. So try these 2 for yourself. Which 2 have a product of 15 and a sum of 8? Which 2 numbers have a product of negative 3 and a sum of 2? I'll give you a moment, you can pause if you want. But our answers 3 and 5, negative 1, 3.